testing for a disease could be made more efficient by combining samples. And this is something that's very often done in disease testing. If samples from 3 people are combined and the mixture is tests, so you basically take samples from 3 different people, mix them together, and you test that one sample. Now, if all 3 people are negative, then the sample will test negative. But if there's one positive sample mixed in there, 1 or more, then the sample will test positive, no matter how many negative samples it is mixed in with the positives. Okay. Assuming the probability of a single sample, just one person, testing positive is 0.1 or 10%. Find the probability of a positive result for 3 samples combined into one mixture. So here's the problem. Find the probability of a positive result for 3 samples combined into one mixture. So let's think about what this looks like. We're taking samples from 3 people and putting them together. So it looks like there's 4 possible scenarios. Everyone could be positive. So 3 positive samples mixed together in one container. Right? And in that case, the overall result will be positive. Or there could be 2 positives and 1 negative in there. So 2 pluses and 1 minus. Remember, it only takes 1 positive for the whole batch to be positive. Or there might be 1 positive sample in there in the mixture, so 1 plus and 2 minuses. And in that case, the sample will also test positive. Remember, if there's at least 1 positive in the mix, then the whole mixture is positive. And the other possible scenario is that there's no positives, no positive samples in the mixture, so 3 negatives. And if all of the individual samples are negative, then the overall result for the mixture will be negative. So find the probability of a positive result. So that's our event. So our event is the overall result is positive, and we want the probability of A. So we want to find P of A, probability of a positive result. Well, there's many ways this could happen, and actually more than 3 ways, because this is very similar to the problem we did earlier about what is the probability if a woman has 3 children that exactly 2 of them are boys. So we had to look at the order that the different genders were being born. The same thing here. If there's 3 positive results, well, that could happen only one way. Let me list them over here. Well, let's see. I'll list them. We'll do green. We'll list them on top. So positive first, positive second, positive third. That's the only way that could happen. But for 2 positives and a negative, well, that could happen multiple ways. First person positive, second person positive, third person negative. Or the first person positive, second person negative. So the negative tests could be of the third person, the second person, or the first person could be the negative. So there's 3 ways that could happen. And so on. So I'm not going to go through the whole list because we don't have to, but the point is these are not all simple outcomes. But there's only one event in the complement of A. So what we're looking for is a positive result, which means what we're not looking for is a negative result. Now, we have this rule of complements, and that's what we're going to use here. And the reason we're going to use the rule of complements is because finding the probability of what we're not looking for is easier in this case than finding the probability of what we are looking for. Okay, so rule of complements. The rule of complements says that the probability of something happening, the probability of A, is equal to 1 minus the probability of not A, or 1 minus the probability that A does not happen. So that's the rule of complements. And we always have this choice. We always have these two options. We could always find the probability of what we're looking for, or find the probability of what we're not looking for and subtract it from 1. The way to choose which approach we take is whichever one's easier. Is our event a smaller list to count, or is the complement of our event a smaller list to count? So in this case, it's the complement. So now let's find, so our goal is to find this, the probability of A. But to do that, let's find the probability of not A. And not A means we're finding the probability of all 3 samples being negative. What is the probability that all 3 samples are negative? Well, going back to the problem, and let me use a different color highlighter here. The probability of a single sample testing positive is 0.1. Okay, so let me scroll down for a little more room. So we're given the probability of 1 positive, 1 plus sign, is 0.1, which means the probability of 1 negative is 0.9. Okay, so the probability of a single negative test is 0.9. So we could use that and the probability that the first person is negative, well, that's 0.9. For any single test, it's a 10% chance of positive, 90% chance of negative. So the first person being negative is 0.9. The second person being negative is also 0.9. And the probability that the third person by themselves is negative is also 0.9. And the multiplication rule says for this sequence of 3 things to happen, we look at the probability of each step and we multiply. So 1 negative, a single negative is 0.9, so 3 negatives in a row would be 0.9 times 0.9 times 0.9. So we need 0.9 times 0.9 times 0.9. Let me pull up the calculator for this. So we'll go 0.9 times 0.9 times 0.9, and we get 0.729. That's the probability that all 3 tests are negative. The first is negative, and the second is negative, and the third is negative. Okay, so 0.729. Let's put that down here. 0.729. All right, so that is the complement of what we're looking for. So the probability of a positive test for the overall result for all the entire batch, the probability of a positive result in the batch is 1 minus the probability of a negative result. And so that's what we're going to do here. And to solve the problem, probability of A is equal to 1 minus the probability of not A, which is 1 minus 0.729. And if we go back to the calculator, let's subtract that previous answer from 1. So we'll say 1 minus 0.729, and that gives us 0.271. And that's going to be the answer to the problem. And let's put that in green, 0.271. So in this case, it was easier to find this probability of not A, 729, because there's only one way that could happen. When the complement could only happen one way, and the event itself could happen multiple ways, you want to count the complement. You want to find the probability of the complement. Okay, so in this case, 1 minus the probability of not A, 1 minus 0.729 gives us 0.271. And that does it for this problem.